Time moves in one direction, like a quiet river you can't step into twice. Moments fall behind us, never returning, while new ones arrive with a softness we hardly notice. And yet, nothing in the universe seems to force time to flow forward, except that it does, unfailingly, like breath. Tonight we follow that gentle current and listen to the story of why time never looks back. Welcome to AstraFlow. Here, science drifts like starlight, and curiosity becomes calm. Tonight, let your thoughts slow down, your breathing find its rhythm, and your mind float through wonder. Before we begin, I'd love to know where you're listening from. Are you lying in bed under city lights? Or resting somewhere quiet with darkness settling softly around you? Tell me in the comments. It's always peaceful to imagine the AstraFlow community scattered across the world, drifting together beneath the same sky. And if this calm journey brings you peace, you can gently support AstraFlow by liking this video or subscribing. It helps this little corner of the cosmos keep glowing. Now, settle in. Let your shoulders ease. Let the day loosen its grip and drift with me into a question older than memory itself. A question whispered by clocks, by stars, by the slow unfolding of the universe. Why does time only move forward? When we say that time moves forward, we're describing something we feel long before we ever understand it. You wake up, breathe, stretch, and the moment is already gone. A cup is emptied, a shadow shifts, a star flickers slightly differently than it did the night before. Everything around you seems to lean in one direction, as if the universe itself is walking down a single path and gently asking us to follow. But what does forward really mean, when the cosmos is so vast and almost nothing seems to hurry? If you look at the equations of physics, the deep, elegant rules beneath reality, they don't choose a direction. They work just as well backward as they do forward. A planet orbiting a star, a particle vibrating in empty space, a beam of light gliding across the dark. None of these motions declare a preferred way. Yet our lives, our memories, and the world we touch insist on a one-way flow. We remember yesterday, not tomorrow. We grow older, not younger. Waves rise and crash, never reversing back into stillness. Somewhere in this quiet inconsistency lives the heart of tonight's question. Maybe forward is not a command written into the universe, but a story emerging from it. A story shaped by change, by unfolding, by the way patterns loosen over time. Maybe forward is simply the direction in which possibilities spread out, like ripples moving away from a stone. Or perhaps forward is the way our minds stitch moments together, giving shape to continuity so we can navigate the world with ease. Tonight, we'll drift through these layers one by one. We'll explore how disorder grows, how the universe expands, how memory forms, and how time, step by gentle step, finds its arrow. You don't need to solve anything. Just let the ideas settle, like dust floating through a beam of late evening sunlight. For now, hold the question softly. If the laws of nature don't choose a direction, why does everything we experience move into the future? To understand why time flows forward, we first need to imagine the universe not as a frozen collection of stars and particles, but as something that remembers. Not in the way a mind does, with stories or emotions, but in the quiet imprint of change. Every moment leaves a trace. Heat fades, light scatters, dust settles where it wasn't before. And once these traces appear, they rarely undo themselves. The universe keeps them, carries them, and builds new moments on top of old ones. In this way, reality becomes a layered book, each page written over the last. From the outside, the cosmos looks calm, almost timeless. Galaxies drift slowly. Nebulae bloom in silence. Yet beneath that stillness lies a constant, gentle rearrangement, energy dispersing, matter shifting, patterns loosening. These slow changes create a sense of direction, a continuing movement from what was to what is becoming. Time's arrow begins here, in the way the universe keeps moving from order toward a wider spread of possibilities. But there's another part to this story. Us. Humans experience time through memory, and memory itself depends on the universe's direction of change. We form memories because our brains, our neurons, our bodies follow the same forward-pointing processes that shape the cosmos. When you recall a childhood afternoon or the warmth of a familiar face, you're leaning on a biological echo of the same forces that guide stars, rivers, and falling leaves. So when we ask, why does time only move forward? We're really asking two questions at once. Why does the universe continually rearrange itself in a single direction? And why do our minds align with that direction so naturally? As we move deeper into tonight's journey, we'll drift gently through the physics behind these questions. Entropy, heat, expansion, gravity. Not to overwhelm, but to soften the mystery. We'll see how the unfolding of the universe creates the unfolding of moments in our lives, and we'll notice how every breath, every quiet memory, every passing thought is part of the same slow current. For now, imagine time as a soft trail of footprints stretching behind you, imprinted in cosmic sand. You don't need to understand every grain, just trust that the universe remembers enough to keep the path steady beneath your feet. Time often feels like a river, steady, quiet, always moving past us even when we are still. You don't see the current directly, you only notice how each moment slips behind you, how a thought becomes memory, how a breath becomes the next breath. This sensation is so natural that we rarely question it. But beneath this softness lies a mystery. Nothing in the laws of physics requires a river at all. The deep mathematics of the universe allow events to unfold forward or backward with equal elegance. And yet, in our experience, the flow moves only one way. Imagine standing at the edge of a slow-moving stream. Leaves drift by in calm procession. If those leaves suddenly reversed direction and floated upstream, the world would feel quietly wrong, as if the rules had folded in on themselves. This is how time behaves in nature, always drifting, never rewinding. The flow is subtle but universal. The cooling of a cup of tea, the fading of a star's light, the spreading of warmth into the air. Each of these changes seems small, but together they create the gentle push that becomes time's arrow. We feel this push even inside our minds. A thought blooms, then dissolves. A sound arrives, then fades. Our brains assemble these changes into a sequence, giving us a sense of before and after. But these inner rhythms are only reflections of something larger, the slow, patient unfolding of the universe itself. Still, the river metaphor isn't perfect. A river has banks, shorelines, places where you can step out. Time doesn't offer that. You can't stand still inside it. Every atom of your body is changing, vibrating, exchanging energy with the world. Even the calmest moment, lying in bed, breath steady, thoughts quiet, is carried forward by countless small shifts. So why does this flow exist at all? Why can we move through time but never around it? The answer begins with a simple idea. The universe prefers the paths that allow more possibilities to blossom. Each moment branches into more arrangements than the one before it. This widening of options, subtle, patient, inevitable, gives time its forward drift. As we move deeper into the night, we'll follow this current more closely. For now, let yourself imagine the soundless river beneath everything, a gentle, ceaseless motion carrying us from one soft moment to the next. If you could shrink yourself down to the scale of atoms, time would look strangely different. Particles dance, collide, drift apart, and the equations that guide them don't care whether these motions run forward or backward. A collision reversed in time looks just as valid as one moving ahead. In the deepest layers of physics, nature is symmetrical. It has no preference, no arrow, no whisper telling events which way to unfold. But when we step back into the world we actually live in, this symmetry feels impossible. A spilled cup won't leap upright. Melted ice won't reform. A moment once lived cannot be lived again. Our lives unfold in one direction, even though the laws beneath them remain reversible. It's a quiet paradox, one that has puzzled thinkers for centuries. How can a universe built on symmetrical rules produce such an overwhelmingly one-way experience? The answer lies not in the laws themselves, but in the patterns that emerge when trillions of particles come together. On the microscopic level, motion is free, but on the human scale, the freedom dissolves into something steadier, softer, an irreversible drift shaped by countless tiny interactions we never notice. Think of a whisper spreading through a room. You could, in theory, play the sound backward and every molecule of air would return to its exact place. But that would require a level of coordination so precise that the slightest disturbance, a breath, a blink, a shift in temperature, would break it instantly. The universe naturally chooses the easier path, spreading sound outward rather than gathering it back in. This tendency isn't forced, it simply unfolds again and again in every corner of reality. And so we find ourselves living inside a story where events accumulate but never unwind. The growing wrinkles of a page, the soft decay of a forgotten leaf, the aging of a photograph, all these small changes belong to a world that never retraces its steps. Even memory follows this rule. You recall the past because it leaves traces, the future leaves none. In this way, our lives become the opposite of physics equations, beautifully irreversible. Each moment carries a direction not because the universe demands one, but because billions of small changes lean, collectively, toward what has not yet happened. Tonight we'll begin tracing that lean, softly, patiently, until the arrow of time reveals itself. If there is one idea that gives time its direction, it is entropy, a word that often sounds harsher than it feels. In truth, entropy is simply the way the universe drifts from tidy arrangements toward looser, more open ones. A sandcastle slowly softens back into a mound. Warm tea cools in a quiet room. A drop of ink spreads until it becomes part of the water. These changes happen gently, naturally, without force or intention, and each one moves in only one direction. You never see tea growing warmer on its own, or ink gathering into a perfect droplet again. This tendency toward disorder is what scientists call the arrow of entropy, and it is the closest thing we have to a universal compass of time. Imagine a deck of cards perfectly sorted by suit and number. There is only one way to arrange it perfectly, but countless ways for the deck to become messy. A single shuffle increases its disorder enormously. Shuffle again, and the number of possible arrangements explodes. Each step opens more room for variation. More pathways, more possibilities. Entropy is simply this widening of options, and the universe, vast and patient, moves effortlessly toward the states where more possibilities exist. In the earliest moments after the Big Bang, the cosmos was astonishingly ordered, smooth, uniform, low in entropy. That rare, delicate beginning allowed time to develop a direction. With each passing moment, matter spread out, temperature differences softened, and the universe expanded into a richer array of possible arrangements. Time's arrow was born not as a rule, but as a natural unfolding. In our daily lives, entropy is gentle. We see it in cooling soup, fading echoes, crumpled sheets. It whispers through the soft settling of dust on a shelf. Nothing dramatic, just the quiet fact that things tend to disperse, loosen, and unwind. And because entropy always increases, it creates a path with a beginning and direction. The past is where arrangements were tighter, more ordered. The future is where they have loosened and spread. Your memories live in the past because the traces that formed them were created in states of lower entropy. The future is blank because nothing has yet left its imprint there. So time moves forward not because the universe pushes it, but because the universe opens. Like a flower blooming, like waves expanding across a lake, entropy widens the horizon of what can be, and we drift gently along that widening. When you look at the night sky, it seems perfectly still. Stars appear frozen in their constellations, drifting so slowly that entire lifetimes pass without visible change. But beneath that quiet canvas, the universe is always rearranging itself. Galaxies stretch farther apart, heat spreads into thinner and thinner space. Clouds of gas expand, cool and drift into new shapes. Even the light from distant stars grows fainter as it travels across the widening cosmos. Every moment is a small shift, gentle, steady, irreversible. This gradual loosening is the universe's rhythm. Not a beat you can hear, not a motion you can watch in real time, but a patient spreading of energy and matter. If entropy is the arrow of time, then the universe's expansion is the soft wind that carries that arrow forward. The cosmos once fit into a volume smaller than a grain of dust, perfectly compressed and astonishingly ordered. Now it has opened into a vast, chilled ocean of possibilities, and the wider it grows, the more room there is for entropy to continue its outward drift. Even the stars themselves follow this flow. They burn through their fuel, releasing heat into space, slowly brightening and dimming across unimaginable spans of time. A young star pulses with energy, an old one cools, fades, and eventually dissolves into dust that may someday become part of a new star. The cycle never reverses. You never see a cooled white dwarf star reignite, gathering back its scattered light. The universe always moves from condensed brightness to diffuse glow. We feel this cosmic unfolding even if we don't notice it. The warmth of your skin drifts into the air. The air, waiting in silence, absorbs it and carries it away. Nothing returns exactly to the way it was. Not heat, not starlight, not the smallest motion of a grain of dust. The universe shifts gently, like a great breath that never exhales backward. So when we say time moves forward, we're also saying this: the universe opens, patterns loosen, energy spreads, and every moment becomes slightly different from the one before it. You don't need to see these changes. Just knowing they happen, softly, persistently all around you, is enough to understand why time has a direction. It points toward openness, toward expansion, toward the unfolding shape of everything that exists. Every star in the night sky is a quiet engine of time. Deep in their cores, hydrogen fuses into helium, releasing light and heat that spill outward into the cold. This outflow is steady, patient, and irreversible. Once a star releases its warmth, that energy will never return to its center. It drifts into space, thinning, fading, softening until it becomes part of the universe's background glow. This simple, gentle, one-way spreading of heat is one of the clearest markers of time's direction. Imagine holding a warm stone in your hand. At first, its heat is concentrated, gathered tightly inside it. But as minutes pass, the warmth flows into your skin, then into the air, then into the room. Eventually, the stone cools, and the heat becomes impossible to trace. You can't gather it back. The universe behaves the same way, always dispersing warmth from places where it is concentrated to places where it is not. Stars are simply the grandest version of that small, familiar process. A star begins as a dense, ordered cloud of gas drawn inward by gravity. Over millions of years, it grows hotter, brighter, more structured. But this order comes with a cost. The star must constantly release heat to stay alive. That heat is entropy in motion, energy dissolving into endless space, adding to the universe's gentle push from past to future. When starlight reaches your eyes, even after travelling for thousands of years, it carries with it the signature of this irreversible flow. As stars age, their light changes. Young stars shimmer with intensity, brimming with stored energy. Older stars flicker softly, their cores slowly emptying of fuel. Eventually they expand into red giants, or collapse into white dwarfs, each step opening into a new arrangement that cannot be undone. A dying star never rebuilds itself into its youthful form. The heat it has given away is gone forever, infused into the vastness. This slow drift of heat shapes everything: the temperature of planets, the glow of galaxies, even the rhythms of life on Earth. Every warm object, every living being, every grain of sand touched by sunlight participates in this one-way exchange. It is the quiet breath of the cosmos. So when you see starlight tonight, faint, ancient, gentle, you're witnessing time itself in motion. A star has let go of its warmth, and the universe has carried it forward. Heat always moves outward, and where heat flows, time follows. If you drop a glass on the floor, it shatters into scattered pieces. The fragments spread outward, each one following a simple path determined by the collision. But no matter how long you wait, the pieces never leap back together. The broken glass does not rewind into its original shape. This feels obvious, almost trivial, yet it reveals something profound about the direction of time. In everyday life, broken things don't unbreak, because the paths that lead to order are extraordinarily rare, while the paths that lead to disorder are countless. Imagine trying to place each shard of the glass exactly where it used to be, down to the smallest crack. You would need perfect knowledge of every splinter, every vibration, every particle of dust on the floor. The universe would have to cooperate with absolute precision. A single breeze, a tiny shift in temperature, or even the warmth of your own hand would be enough to prevent the pieces from reassembling. Disorder is the natural resting place. Not because nature prefers it, but because there are infinitely more ways for things to be scattered than to be perfect. Entropy is simply this imbalance written into the fabric of reality. The whole glass represents one highly ordered arrangement. A shattered glass represents millions and maybe billions of possible arrangements. Each of those arrangements is easier to reach than the original, so time naturally flows toward them. The more possible ways something can be arranged, the more likely the universe is to drift into those configurations. We see this everywhere. A candle burns down but never builds itself back up. Smoke swirls outward but never gathers back into a sharp line. A drop of cream dissolves into coffee but never unmixes. These small, quiet changes are the daily footprints of entropy. Even memory follows the same rule. You can remember a moment because your brain formed a pattern, a trace, in a lower entropy state. But you can't remember the future because those traces don't exist yet. The future is open, scattered, unformed. The past is arranged, fixed, written. When something breaks, it moves from one specific arrangement into a sea of countless others. Time flows in the same direction, from the rare to the common, from the arranged to the dispersed, from the precise to the possible. And so, the broken glass becomes more than an accident. It becomes a quiet teacher, reminding us that time's direction is woven into the way the universe allows patterns to loosen, but not rewind. Memory is one of the clearest signs that time has a direction. You can recall your first day of school, the laughter of a friend, the warmth of a morning long gone, but you cannot remember tomorrow. You cannot recall a moment that has not yet happened. This simple truth, woven into every human life, reveals a deeper connection between time's arrow and the way the brain forms patterns. When you experience something, a sound, a feeling, a sight, your brain rearranges itself ever so slightly. Neurons fire in new sequences, connections strengthen, chemical signals leave faint traces that shift the structure of the mind. These rearrangements are not reversible. Once a trace is made, it cannot return to a state of never having existed. You can forget something, but you cannot erase the fact that your brain once held it. Like footprints in soft sand, the impressions may fade, but the sand is never exactly the same again. This means memory is not merely a mental phenomenon, it is a physical one, an expression of entropy unfolding inside you. When a memory forms, your brain uses energy, generates heat, and increases disorder. In doing so, it creates a stable, lasting mark. That mark belongs to the past because it required a flow from lower entropy to higher entropy to take shape. The future, by contrast, remains empty of such traces. Imagine a book being written one word at a time. The pages behind you are filled with ink, fixed, recorded. The pages ahead remain blank. You cannot read what has not yet been written. Memory works the same way, and yet this directionality is gentle. We don't feel entropy rising inside our minds. We feel the sweetness of nostalgia, the weight of experience, the quiet reassurance that we have lived through moments that shaped us. The brain takes the universe's irreversible processes and transforms them into something human, something tender. Even animals, even simple creatures share this form of direction. A bird remembers where it once found food. A mouse recalls the scent of danger. Each memory is a small proof that time flows forward at every level of life. So when we ask why time does not reverse, the existence of memory offers one of the softest answers, because the patterns of the past are written into us and the unwritten future waits ahead. If memory marks the past, then perception marks the present, and together they turn the mind into a kind of compass, always pointing in the same temporal direction. You never have to think about which way time is moving. Your brain quietly orients you. It anchors you in now, recalls before, and imagines after. Without these 3 points, the world would feel disordered, floating, almost dreamlike. The mind gives structure to time's river, even as it flows through us. Every sensation you experience arrives with a delay so small you'll never notice it. Light touches your eyes, sound enters your ears, and signals travel through nerves before the brain assembles them into a coherent moment. By the time you become aware of something, it is already in the past, a few milliseconds behind reality. Yet the mind blends these signals seamlessly, smoothing them into a single, flowing present. This blending is one of the brain's most delicate illusions, creating the feeling of a continuous now drifting forward. Just as a compass needle aligns with Earth's magnetic field, your perception aligns with the arrow of time created by entropy. You sense events in the order they unfold. You feel cause and effect as naturally as breathing. When you see a glass fall, you expect it to shatter, not rise. When you throw a ball, you expect it to move away, not return to your hand. These expectations are not conscious calculations. They are woven into the structure of thought, shaped by a lifetime of living in a world where time only moves in one direction. The mind also looks ahead. It predicts, it imagines, it rehearses possibilities, projecting them into the blank space we call the future. This ability to envision what has not yet happened is uniquely human, and it relies on the same processes that store memories. The brain uses past patterns to forecast what might come next, turning lived experience into gentle guidance. In this way, the mind becomes both map and traveller, navigating the landscape of time without ever stepping outside it. Memory anchors the past, perception shapes the present, imagination reaches toward the future. Together they create the feeling that we're moving forward even if our bodies are perfectly still, and so, without effort, the mind traces time's direction, quietly, continuously, like a compass needle following an invisible field. When we drift down into the quantum world, the realm of particles, waves, and delicate uncertainties, time begins to behave in ways that feel almost dreamlike. The smallest pieces of reality don't follow the clean, orderly progression we see in daily life. They flicker between possibilities. They exist in blurry states. They behave as if before and after are less important than the shimmering cloud of what might be. In this tiny domain, the arrow of time becomes far less rigid. A single particle can move forward or backward through time in the equations that govern it. Quantum mechanics allows paths to be traced in both directions, as if time itself doesn't discriminate. A particle in motion looks just as valid whether you reverse its journey or replay it in the usual order. Only when many particles come together, forming atoms, molecules, and eventually the world we touch, does the familiar one-way flow reappear. This is one of the universe's softest secrets. Time's direction does not begin at the smallest scales. It emerges later, as complexity grows and entropy starts to rise. In the quantum realm, particles don't experience a past or a future. They simply exist within a haze of probabilities. A particle can tunnel through barriers, appear in unexpected places, or behave as both wave and point at the same moment. These behaviours give us inventions like lasers, semiconductors, and much of the modern world, yet they also remind us that the rules we live by are not the rules that everything lives by. Consider a simple image, a small leaf floating on a pond. At the surface, the world you can see, the water flows gently in one direction, but deep below, currents swirl unpredictably, looping and dancing without clear order. Quantum reality is that deeper water, fluid, uncertain, reversible. So why doesn't this quantum ambiguity make our entire world reversible too? Because the moment quantum systems interact with their surroundings, their delicate reversibility collapses. They become tangled with trillions of particles, entropy increases, patterns settle, and time's arrow reasserts itself steady and calm. In this way, the quantum realm teaches us something profound. Time's direction is not a fundamental command written into nature's smallest parts. It is a property that blossoms when many tiny pieces come together, when the universe gathers enough complexity to develop a memory, and from that memory, the forward flow begins. If there is one arrow the universe consistently follows, it is the thermodynamic one. The quiet, steady drift of heat from where it is concentrated to where it is not. This movement is subtle, almost invisible, yet it shapes everything from the cooling of a cup of tea to the life cycle of stars. Whenever heat spreads, entropy increases, and wherever entropy increases, time gains its direction. The thermodynamic arrow is the simplest, softest explanation for why we remember the past but never the future. Imagine standing near a small fire on a cold night. Heat pours outward into the air, warming your skin, fading gently as it travels. You never see warmth gather itself back into the flame. The outward flow is natural, effortless, and irreversible. At the microscopic level, countless particles are exchanging energy in every direction. But the overall tendency, when you step back far enough, is always the same. Warmth spreads, gradients soften, sharp differences blur into smoother ones. This smoothing out is entropy at work, and it always increases. Not because the universe prefers disorder, but because disordered states vastly outnumber the ordered ones. If you could watch billions of particles at once, you would see that the thermodynamic arrow is not a law that forces them forward. Instead, it is a statistical truth, a gentle push that becomes overwhelming when many particles act together. One particle may move backward in time mathematically, but trillions of them, sharing heat, sharing motion, spreading energy, create a trend so strong it becomes the world we experience every moment. This arrow even shapes the biology inside you. Every heartbeat releases a little heat. Every thought uses energy that eventually disperses. These small thermodynamic changes create the irreversibility of life, the forward march of aging, healing, remembering and becoming. Even the great cosmic landscape follows this arrow. Stars release light into space. Galaxies radiate heat. The universe itself cools as it expands. All these processes involve energy flowing outward, never inward, giving the cosmos its gentle tilt from past to future. The thermodynamic arrow also explains why we can't unscramble events. A mixture of warm and cool air never spontaneously separates into hot and cold again. A scent released into a room never gathers back into the bottle. The flow of energy is always toward dispersal, toward openness, toward the unfolding of possibilities. And so, time's direction is woven into every warm breath, every fading ember, every soft exchange of energy around us. Where heat flows, time follows. If entropy gives time its direction on small scales, the expansion of the universe gives it direction on the largest ones. From the moment of the Big Bang, space itself has been stretching, widening, opening like a vast and silent flower. Galaxies, once pressed close together, now drift apart in a gentle cosmic migration. This continuous expansion, slow, steady, unstoppable, forms what scientists call the cosmological arrow of time. When the universe was young, everything was packed into an incredibly ordered state. Temperatures were high, but uniform. Matter was evenly distributed. Energy was concentrated and smooth. This rare and delicate arrangement provided a foundation for time's arrow to emerge. As space expanded, tiny fluctuations grew into stars, galaxies and clusters. Heat dispersed across widening distances. The universe's possibilities multiplied. Entropy rose. Imagine blowing up a balloon slowly. At first, the air inside is compressed and tidy, but as the balloon inflates, the air spreads out, exploring new space, settling into more varied arrangements. The expanding universe behaves similarly, except on a scale so enormous that human imagination barely grazes its surface. This expansion ensures that once energy spreads, it has more and more room to disperse into, making it nearly impossible for the universe to retrace its steps. Starlight moves outward and never returns. Galaxies drift apart and will never gather back into their original compact configuration. Expansion creates a one-way opening, a widening of cosmic space that mirrors the widening of entropy itself. Even the cosmic microwave background, the faint afterglow of the early universe, tells this story. Its temperature today is cooler than it was yesterday, cooler still than it was 1 million years ago. Every moment, the universe stretches the light that fills it, softening it, lengthening its wavelength, draining its heat. It's a quiet reminder that time's flow is tied to this cosmic stretching, and so, the cosmological arrow aligns with the thermodynamic one. Both point forward. Both arise from the universe's initial conditions, a structured beginning that gradually unfolded into something far more open and varied. If the universe were contracting instead of expanding, time might appear to behave differently. But in our reality, expansion is the great signature of the future. This widening cosmos is the stage on which every moment of your life unfolds. We drift forward not only because entropy grows, but because space itself is gently carrying us into tomorrow. Beyond physics and cosmic expansion, there is another arrow of time, one that lives inside you. It is not written in equations or galaxies, but in experience. This is the psychological arrow of time, the quiet sense that life moves in a single direction, from childhood to adulthood, from learning to understanding, from uncertainty to memory. You may not feel the universe expanding, and you cannot see entropy rising, but you feel this arrow deeply. It is the soft current that shapes how you remember, how you anticipate, how you grow. Your mind organizes events in a meaningful order. You recall yesterday. You live inside today. You imagine tomorrow. This simple sequence gives structure to your entire existence. Without it, Thoughts would feel scattered, emotions would drift without anchor, and the world around you would lose its sense of continuity. The psychological arrow is how the brain makes sense of the universe's physical arrow, by turning it into a narrative you can walk through. Consider how a story unfolds. A beginning sets the foundation, a middle adds change, an ending resolves the thread. Life mirrors this pattern. The decisions you've made shape your present. The experiences you've lived shape your identity. The possibilities ahead shape your hopes. You never confuse these directions, not because you consciously track them, but because your brain is built to follow the one-way flow of time. Prediction also plays a role. The mind constantly simulates the future, planning, protecting, preparing. When you cross the street, you anticipate the car's motion. When you speak, you imagine the listener's response. These small predictions rely on the fact that time moves forward. If events could randomly reverse, the world would feel unstable and unknowable. Your brain depends on time's reliability to keep you safe. Emotion, too, carries a temporal direction. Joy often looks forward. Nostalgia looks back. Healing requires movement through time, a slow unwinding of difficulty or loss. Even laughter, even sadness, unfolds like a wave, cresting and fading in a rhythm that you feel but cannot control. The psychological arrow is not separate from physics. It is its echo. Entropy increases and memory forms. The universe expands and experience deepens. You become a living reflection of the cosmos' one-way drift. So while stars mark time with their light, you mark it with your thoughts, a quiet journey from who you were toward who you are becoming. If time has a heartbeat, it is light. Every moment of your life is illuminated, literally, by tiny packets of energy rushing forward at the universe's ultimate speed. Light does not pause, it does not slow. It does not wander. It moves straight ahead, from one instant into the next, like a cosmic metronome ticking out the rhythm of reality. In many ways, the direction of time is tied to the direction of light. Consider what happens the moment you open your eyes. Photons that left a lamp a billionth of a second ago, or left a star years ago, or left the early universe eons ago, land gently on your retinas. These photons have been travelling forward, always forward, never bending backward into the past. When they touch you, they deliver information only from where they have already been. Light carries the past to you, not the future, and so your experience of the world depends on this forward delivery of information. In Einstein's theory of relativity, light occupies a special place. At light speed, time itself does something astonishing. It stops. From the perspective of a photon, there is no passage of time between emission and arrival. A beam of sunlight leaving the surface of the sun and reaching Earth 8 minutes later experiences that entire journey as 0 seconds. Light is timeless, and yet it defines time for everything that moves more slowly. This paradox reveals something profound. For objects with mass like planets, people, and stars, time stretches and bends. It slows near strong gravity and speeds up in emptier space. But for light, none of this applies. It remains constant, unchanging, independent of the shifting fabric of space-time. Its unwavering speed becomes the foundation upon which time itself is measured. Because light behaves consistently, we can define seconds, track events, and understand cosmic distances. Imagine light as an endless stream flowing across the universe. Where it shines, time reveals itself. Where it fades, time becomes harder to perceive. Every clock, from wristwatches to pulsars, ultimately depends on the regularity of electromagnetic waves, ripples of light, to keep rhythm. Even the subtle glow of the cosmic microwave background, the faint residue of the early universe, acts like a giant clock that has been cooling for nearly 14 billion years. Its temperature, its wavelength, its slow stretching tell us how much time has passed since the universe began. So as you rest tonight, think of time as illuminated by light, a gentle radiance travelling forward through the cosmos, carrying the story of where things have been, guiding everything toward the moments yet to come. To understand why time flows forward, we must return to the earliest moment the universe ever knew, a fraction of a second after the Big Bang, when everything we see, touch and feel was compressed into an unimaginably small, hot, ordered state. In that moment, something subtle happened. A tiny imbalance, a quiet tilt, appeared in the fabric of reality. This first asymmetry is what allowed the universe to unfold rather than collapse, to grow rather than remain still, to drift into the future instead of hovering in a timeless equilibrium. At the beginning, matter and antimatter were created in almost equal amounts, but not perfectly equal. For every billion particles of antimatter, there were 1,000,001,000 particles of matter. That single extra piece in each billion, the slightest cosmic preference, tipped the scales. When matter and antimatter collided, they annihilated one another, releasing energy. But because matter had a whisper-thin advantage, a tiny remnant remained. That remnant became everything: stars, planets, oceans, your breath, your heartbeat, your thoughts. This tiny imbalance set the stage for entropy to rise. A perfectly symmetrical universe would leave no room for change, no way for complexity to grow. Symmetry is elegant, but it is still. The slightest breaking of symmetry is what allowed the universe to move, expand, evolve, and eventually cool into forms where life could emerge. Imagine a perfect round hill. If you place a ball at the top, it could roll in any direction. There is no preferred path. The slightest push, a breath of wind, a vibration, a grain of dust shifting, will make the ball choose one side. From then on, the direction is fixed. That first push doesn't force the ball to roll forever, but it defines the beginning of the path. The universe's early asymmetry was that gentle nudge, choosing a direction for time before time had even settled into meaning. When the cosmos expanded and cooled, atoms formed, stars ignited, galaxies swirled into structure. Each step, each transformation, followed from that first imbalance, a universe that was not perfectly even, not perfectly symmetrical, not perfectly still. This imperfection was a gift. It opened the door for complexity, motion, and eventually consciousness. The arrow of time did not appear suddenly. It blossomed from that initial tilt, a whisper of unevenness that allowed the universe to unfold rather than remain suspended. And so, the flow of time we feel in every breath traces back to that first moment of cosmic choice, when symmetry cracked just enough for the story of existence to begin. Time does not flow at the same speed everywhere. It stretches in some places, tightens in others, and shifts gently depending on how fast you move or how close you are to something massive. Einstein revealed this with a quiet elegance. Time is woven into space, and together they bend in response to matter and motion. This means time is flexible, soft, elastic, responsive. Yet even with all this bending and stretching, time still never reverses. It never folds back onto itself. Imagine two clocks ticking side by side. One stays with you on Earth. The other travels near the speed of light or sinks deep into a strong gravitational field. When the two clocks reunite, they will disagree. The travelling clock will have experienced less time. This is time dilation, not an illusion, but a true difference in the passage of time caused by motion or gravity. And yet, even though time slows, it does not run backward. A fast-moving astronaut may return younger than they would otherwise be, but they do not return to a previous moment. A clock near a black hole may tick at a fraction of its normal rate, but it never rewinds. Time's flow can change its pace, but never its direction. Why? Because all the bending and slowing of time still unfold within the greater framework of entropy. The universe continues its gentle expansion. Heat continues to spread. Patterns continue to loosen. These processes form a background current that none of relativity's distortions can override. Even at the edge of a black hole, one of the most extreme environments in existence, entropy still increases. The arrow still points outward, toward the future. Picture a river again. The water may speed up near rocks, slow in a wide basin, or swirl in small eddies, but its overall direction remains the same. The details change, but the flow does not. Time behaves similarly, flexible in speed, unwavering in orientation. There's also a deeper reason time cannot reverse. Reversal would require every particle in the universe to trace its steps perfectly backward. Every photon would need to return to its source. Every molecule would need to reassemble its former structure. The slightest imperfection, a stray vibration, a passing speck of dust, would break the reversal instantly. The universe's immense complexity makes backward motion effectively impossible. So while relativity shows us a world where time stretches and compresses like a gentle fabric, entropy ensures that the fabric always unfurls in the same direction. Time can slow, time can bend, but it never looks back. Gravity is more than a force pulling objects together. In Einstein's view, it is the bending of space-time itself, a soft curvature that shapes the paths everything follows, including the flow of time. Where gravity is strong, time moves slowly. Where gravity is weak, time moves a little faster. This gentle stretching and squeezing gives the universe a rhythm that is almost musical, a cosmic tempo shaped by mass, motion and curvature. Imagine placing a heavy stone on a stretched sheet. The sheet dips, forming a curve. A marble rolling nearby spirals inward, following the shape created by the stone. Gravity works in a similar way, except the sheet is space-time, and the marble is everything. Planets, light, even the seconds passing around you. Near Earth, gravity slows time just enough that satellites must correct their clocks to stay synchronized with ours. Without this adjustment, navigation systems would drift, and our technology would lose its precision. Time is not universal. It is local, shaped by the gravitational landscape through which it flows. And yet, despite these variations, time still moves forward everywhere. A clock on a mountain ticks a little faster than one at sea level, but neither runs backward. They simply drift at different speeds along the same irreversible path. Gravity alters the pace, not the arrow. This has a profound implication. Moments feel different depending on where they are in the universe. Near a black hole, time stretches dramatically. A minute for an orbiting astronaut could be hours, days, or even years for someone far away. This isn't science fiction. It's a quiet truth of relativity. Gravity deepens the riverbed of time, slowing its current. But even at the edge of a black hole, where space-time curves almost to breaking, entropy still increases, heat still spreads, space still expands, the universe still moves toward greater openness. And so the arrow of time remains unbroken. Think of the moments in your own life. Some feel heavy, dense with emotion or meaning. Others feel light and fleeting. These differences echo the way gravity shapes time, how some moments seem to stretch while others rush by. Yet all of them carry you gently forward, never backward. Gravity anchors the universe, it sculpts motion, it shapes the tempo of existence. But even as it bends the flow of time, it cannot reverse it. The arrow continues, guided by entropy, expansion, and the soft unfolding of the cosmos. Every moment you experience, light or heavy, brief or lingering, is part of that forward drift. Black holes are the most mysterious places in the universe. regions where gravity becomes so strong that nothing, not even light, can escape. They're often imagined as cosmic traps, swallowing everything that comes too close. But perhaps their most intriguing feature is the way they shape time. Near a black hole, time slows dramatically. At its edge, the event horizon, time seems to nearly stop for an outside observer. And yet even here, in the most extreme environment imaginable, time never reverses. It stretches, distorts, lengthens, but always flows forward. Imagine drifting toward a black hole from a safe distance. Your clock ticks normally from your own perspective. You feel your heartbeat, your breath, each second passing as it always has. But someone watching you from far away sees something strange. Your motion appears to slow, your signals become more stretched, your image fades as though the universe itself were pulling time apart. This difference is not illusion, it is the shape of space-time responding to immense gravity. At the event horizon, time dilation becomes extreme. A single second for you could be thousands of years for someone observing from a distance. If you fell in, your journey would continue forward, but their ability to witness it would blur and eventually vanish. Time behaves differently depending on where you're positioned relative to gravity, but its direction remains the same. Inside a black hole, physics becomes uncertain. Our equations stretch, twist, and eventually fail. We don't know whether time continues as a recognizable dimension or transforms into something else entirely. Some theories suggest that space and time might swap roles. Others propose that the interior is a passage to another region of space-time. And yet all these ideas share one common feature. None of them allow time to run backward, because that would require entropy to decrease. An impossibility given everything we know. Even black holes obey the arrow of time. When they absorb matter, entropy rises. When they emit faint Hawking radiation over trillions of years, entropy rises still. Even their eventual evaporation, a slow whisper of energy back into the cosmos, is a forward-moving process. In a sense, black holes are not violations of time, but guardians of its flow. They stretch it, test it, slow it, but they do not break it. They sit at the edge of what we understand, reminding us that even in the universe's darkest wells, the arrow of time points outward. So when you imagine a black hole, imagine not a trap, but a place where time becomes soft, stretched like taffy, diluted into near stillness, yet always flowing forward into the unknown. Entropy can feel like an abstract idea, something belonging to laboratories, equations, or distant stars. But in truth, it unfolds around you constantly, touching every small corner of daily life. If you look closely, you can see the arrow of time written in familiar, ordinary things, in cooling coffee, in fading paint, in the way a room slowly drifts from tidy to lived in. Entropy is not loud. It is not violent. It is a soft, patient shift that accompanies every moment. Imagine setting a warm cup of tea on the table. At first, the heat is concentrated, held tightly in the liquid. But as minutes pass, warmth flows outward, into the cup, into the air, into everything nearby. You can feel the arrow of time in that simple cooling. No matter how long you wait, the warmth will never spontaneously gather back into the tea. The universe always moves from concentrated energy toward a broader, more even distribution. A scent drifting through a room behaves the same way. Perfume released into the air spreads quickly, filling the space with its presence. You never see the molecules reverse their paths and return neatly to the bottle. The spreading is natural, not because disorder is preferred, but because there are countless more ways for the scent to disperse than to stay contained. Even your belongings follow entropy's rhythm. A neat desk becomes cluttered unless effort is applied. Clothes wrinkle, fruits ripen and soften, books yellow with time. All these small changes point toward the same direction of motion. from ordered arrangements into more open, more scattered ones. Life itself participates in this gentle drift. Every breath you take increases entropy as warm air leaves your lungs and mingles with the cooler air around you. Every thought you form requires energy, releasing tiny amounts of heat. Even when you sleep, your body follows this cosmic rule, maintaining order within but contributing to increasing entropy overall. Entropy explains why we remember the past but not the future, why we can mix ingredients but cannot unmix them, why moments feel like they slip away rather than return. It is the subtle engine behind every irreversible process, whether grand or mundane. When you notice something changing, a candle melting, a puddle evaporating, ice turning to water, you're witnessing time's arrow expressed in everyday language. These gentle changes are reminders that the future is simply the direction where entropy continues to rise. And as ordinary as that sounds, it is what binds your life to the unfolding of the universe. Life is often described as orderly, a miracle of structure in a universe that naturally drifts toward disorder. A single cell contains thousands of organized reactions, billions of precisely arranged molecules, and a delicate architecture that sustains itself moment by moment. Compared to the spreading of heat or the dissolving of patterns, living things seem almost rebellious. They grow, repair, build, and maintain form. In a world where entropy rises, life appears to push back. But this defiance is not a violation of nature's rules. It is a beautiful balance. Life decreases entropy locally by increasing it elsewhere. Every heartbeat, every movement, every breath uses energy, which then spreads outward as heat, increasing the overall disorder of the surrounding environment. In exchange, life maintains or builds its own internal order. Imagine a plant reaching toward the sun. To form a new leaf, it must assemble complex molecules in careful arrangements. This takes energy. And as the plant uses sunlight to create this structure, it releases heat into the world, raising entropy around it. The plant becomes more organized precisely because the universe around it becomes slightly less so. Humans, too, are small oases of order in a sea of increasing entropy. Your body constantly fights decay, repairing cells, maintaining temperature, organizing nutrients, forming memories. But every act of preservation requires energy, and that energy, when used, spreads outward. You radiate heat, leave footprints, produce sound, exhale warm air. You create order within by releasing disorder without. This is not a contradiction, it is partnership. Life's ability to sustain structure comes from the irreversible processes that time's arrow provides. Even reproduction, the creation of a new, highly organized being, depends on this flow. A growing embryo builds staggering complexity from simple beginnings, yet every step generates heat, a byproduct that increases entropy. The more intricately life arranges itself, the more energy it consumes, and the more entropy the universe gains. Entropy is not life's enemy. It is the river that allows life to exist at all. Without the flow of energy from hot to cold, from concentrated to dispersed, there would be no gradients to fuel metabolism, no sunlight to warm planets, no chemical reactions to sustain growth. Life thrives because entropy rises, not despite it. In this way, life becomes a gentle defier of disorder, but only briefly. Eventually all living systems return to the wider drift of the universe, releasing their carefully maintained order back into the flow. But while life remains, it glows, a temporary island of structure in a sea moving steadily toward tomorrow. Memory feels solid, like a shelf of books you can revisit whenever you choose. But in truth, memory is fragile, a delicate pattern of electrical and chemical traces shaped by time's forward motion. Each recollection you hold exists only because your brain once followed entropy's arrow, using energy, releasing heat, and forming new neural connections that cannot be undone. The past is something your mind has already written. The The future is something it has not yet had the chance to shape. When you remember something, a childhood room, a voice, a scent drifting through summer air, your brain does not simply play back a recording. It reconstructs the moment, gently assembling fragments that have been weakened, altered, softened by time. Memory is an act of creation, not preservation, and because those fragments depend on irreversible processes, memory itself becomes a testament to the one-way drift of time. A memory begins as a fresh imprint. Neurons fire, synapses strengthen, proteins arrange themselves in new patterns. But these arrangements are never perfect, never static. They fade, reorganize, blur at the edges. Entropy does not erase them outright, but it loosens their precision. What was once sharp becomes atmospheric, like a photograph left in sunlight, slowly losing colour yet somehow gaining emotional warmth. The fragility of memory reveals a quiet truth. We remember the past because it has happened and because it has left traces, but we cannot remember the future because no traces exist there yet. The future is not written. It is spacious, unformed, waiting. Memory anchors us to one side of time's arrow. Even dreams echo this fragility. They remix fragments of lived experience, blending them into shapes that feel both familiar and impossible. Dreams do not follow chronological order because memory, when loosened from waking logic, drifts freely. This drifting reminds us that the brain is not a machine obeying rigid rules, but a soft network shaped by the same cosmic processes that guide stars, storms, and galaxies. Sometimes memory feels too fragile, names slipping away, moments fading, days blending. Yet this softness is part of what makes memory human. It allows the past to mellow, to heal, to transform. The mind protects what matters most by letting everything else drift downstream. If memory were perfect, we might feel trapped in what has already happened. Instead, its fragility gives space for the present to breathe and for the future to open gently in front of us. In this way, memory is both a gift and a reminder. We live on a one-way path because the universe writes its story only once. When you dream, time loosens. The strict sequence that orders your waking life softens into something fluid, drifting, unanchored. Events fold into one another, places appear without introduction, people from different chapters of your life stand side by side as if time has forgotten to maintain its boundaries. In dreams, the arrow of time is not broken, but it becomes quiet, gentle, almost irrelevant. During sleep, your brain disconnects from the steady stream of sensory input that normally keeps you grounded in the present. Memories rise to the surface, not in tidy order, but in shimmering fragments. The mind revisits feelings, echoes, textures, blending them into narratives that do not obey the rules of physics or chronology. A childhood memory can follow the image of tomorrow's task. A moment of fear can dissolve instantly into joy. The dream state rearranges time the way an artist rearranges colours on a palette. This does not mean time runs backward in dreams. Rather, the brain temporarily relaxes its grip on the psychological arrow, the sense of before and after that structures your waking awareness. Because dreams are not anchored to sensory reality, they do not need to follow the forward flow. They float freely within a region where memory, imagination, and emotion blend. Imagine drifting through a quiet lake at night. The surface reflects the stars, but the reflection ripples, blurs, reshapes itself. Nothing is fixed. Dreams are like that reflection, a place where the mind explores without direction, moving by association rather than sequence. Neuroscientists believe dreaming serves many purposes: processing emotions, consolidating memories, refreshing the mind. In doing so, the brain replays fragments of experience, but it does not do so in the original order. Entropy in neural networks ensures that memories stored across billions of synapses will not reconstruct themselves perfectly. Dreams arise from this imperfect reconstruction. They are born from time's arrow, yet they drift beyond it. This drifting reminds us of something profound. The flow of time as we experience it is a construction of the waking mind. Without attention, without sensory grounding, without the need to navigate the world, the brain stops enforcing the strict sequence of now, then, later. It lets time become a soft field of impressions rather than a line, and when morning comes, the arrow returns, the mind reorients, the world regains order, moments line up once more, one after another. Dreams offer a nightly glimpse into a universe where time does not need to move forward, a brief, weightless reminder that our sense of time is both real and beautifully flexible. Life carries its own version of the arrow of time, a quiet sequence woven into every breath, every heartbeat, every unfolding moment within a living body. Unlike the reversible equations of physics, biology is full of processes that move in only one direction. Cells divide, age, and eventually cease. Organisms grow from simplicity into complexity, then soften, slow, and return their order to the wider world. Biology does not run backward because the chemistry of life depends on energy flowing forward. Consider the simplest marker of time in your body, aging. Every cell contains intricate molecular machinery that copies DNA, repairs damage, and maintains structure. But these processes are never perfect. Errors accumulate, proteins misfold, telomeres shorten, mitochondria wear down. These tiny imperfections, gentle, inevitable, form a biological arrow that cannot be reversed. Entropy touches every part of life, not harshly, but persistently. Growth itself follows a one-way sequence. An embryo becomes a child becomes an adult. Organs develop, refine, stabilize, but the path cannot be retraced. You cannot return to the exact biological state you once had because the energy and molecular arrangements that shaped you were used, spent, and dispersed. Moved along the arrow of time, even the daily rhythms of the body flow forward. Your sleep cycle, hormone release, hunger signals, body temperature, all follow circadian patterns that drift through the hours with a clear sense of direction. The ticking of this internal clock depends on chemical reactions that proceed only one way, consuming energy and releasing heat. Memory, too, is biological. Each new memory requires energy, generates heat, and forms a pattern that did not exist before. Because energy flows outward after it is used, the process cannot be reversed. You cannot unlive a moment or erase the fact that your neurons once fired in a certain way. Biology writes its story once, on the living medium of the body. Even reproduction reflects time's arrow. Life begins in a state of extreme order, a single fertilized cell, and then blossoms into staggering complexity. That complexity cannot be unbuilt step by step, because each stage requires energy and produces entropy. The flow of life depends on the direction of chemical gradients, sunlight, and nourishment. Without the forward movement of energy, life could not grow, repair, or even exist. In this way, biology becomes a soft mirror of the universe, a living expression of the same principles that guide stars, planets, and galaxies. Time moves forward because energy does. Life grows forward because time does. And inside you, each heartbeat is a quiet reminder. You are part of this gentle, irreversible flow. Long before humans created clocks, the universe kept time. It marked the passing of moments with rhythms far older and steadier than any device we could build. These cosmic clocks, the spinning of planets, the pulsing of stars, the echo of ancient radiation, shape the tempo of reality itself. And although each one tells time differently, they all point in the same direction, forward. Consider the rotation of Earth. Every sunrise is a turn of the planet, a measurable, repeating moment in an ongoing sequence. We built calendars around this rhythm, but the rhythm itself belongs to the cosmos. No day is identical to the last. Tides shift, air currents change, continents drift. Even Earth's rotation slowly slows as the moon pulls on it, a quiet reminder that even cosmic clocks age. Then there are pulsars, the rapidly spinning remnants of massive stars. These collapsed stars emit beams of radiation like cosmic lighthouses, each rotation producing a pulse so regular that pulsars are among the most precise clocks in existence. Their beams sweep the sky at intervals stable enough to rival atomic clocks, ticking millions of years into the future. Yet even they slowly lose energy, spinning more leisurely over time. Their tick, too, carries the mark of entropy's drift. Far beyond stars and planets lies an even older clock, the cosmic microwave background, the faint afterglow of the Big Bang. Its light has been cooling for nearly 14 billion years, stretching into longer wavelengths as the universe expands. Each degree of cooling marks the passage of cosmic time. The CMB does not pulse or rotate, it simply fades softly, like the universe's slow exhale. Its very existence proves that the early universe was hotter and more ordered, and that time has flowed steadily since. These cosmic rhythms give structure to the universe. They allow astronomers to measure distances, predict celestial motions, and trace the evolution of galaxies. They reveal how stars age, how galaxies collide, how the universe grows. Every one of these processes is irreversible. A star cannot unburn its fuel. A galaxy cannot unmerge after colliding with another. The cosmic clocks do not tick backward because the universe does not return to earlier states. Even your perception of time depends on these rhythms. Your body synchronizes with daylight. Your mind uses cycles of sleep and wakefulness to track the flow of days. You live within a web of cosmic oscillations that guide the pace of your life without you ever noticing. The universe keeps time in countless ways, vast, slow, radiant, quiet, yet all of them trace a single current, moving gently, inevitably forward. The mind is a remarkable storyteller. It can replay the past with warmth or clarity. It can imagine the future with hope or caution, yet these two abilities are not symmetrical. We remember the past, but we can only imagine the future. One is a trace of what has already happened, the other is a construction of what might be. This difference reveals another aspect of time's arrow, one that lives inside the architecture of the brain. Memory is anchored in physical change. When you experience something, your brain alters itself, connections strengthen, patterns shift, traces form. These changes require energy and increase entropy, making them irreversible. Once a memory is formed, it belongs to a direction, the direction from lower entropy to higher. You cannot form a memory of something that has not happened, because there is no trace yet for your brain to store or modify. The future, however, is built differently. When you imagine something, a dream, a plan, a worry, the brain uses fragments of past experiences and combines them in new ways. It borrows textures and emotions from memories but arranges them into possibilities rather than facts. This is why imagined futures can feel vivid yet unstable. They are mosaics, assembled rather than inherited. Imagine standing at a window watching clouds drift. The clouds you see are real, anchored to the present moment. But when you imagine where they will move next, your mind creates a prediction. This prediction may be accurate or not, but it is fundamentally a guess, a soft projection into a space not yet written. The reason imagination works at all is because the past exists as a library of patterns. You use these patterns to anticipate what might come. This is useful. It keeps you safe, helps you plan, guides your choices. But anticipation is not memory. It is a forward-facing ability, supported by the same irreversible processes that make memory possible. There is another layer to this, the emotional weight of time. The past carries nostalgia, a gentle ache or warmth for what once was. The future carries hope and uncertainty, emotions that lean into what has not yet arrived. This emotional asymmetry deepens the psychological arrow of time, reinforcing the divide between what we know and what we can only imagine. In this way, the mind mirrors the universe. Entropy writes the past, possibility writes the future, and we, standing between the two, experience time as a flow that moves us from what has been toward what may someday be. We often speak of the present moment as if it were something solid, a single point in time we can inhabit fully. But the truth is softer, stranger, and more delicate. The present is not a precise instant. It is a construction of the brain, a stitched together impression created from signals that arrive slightly out of sync. Light reaches your eyes, sound reaches your ears, touch travels through your nerves, all at different speeds. Your brain gathers these scattered signals and blends them into what feels like a seamless now. In reality, the present is already the past by the time you experience it. Neural processing takes time, a few milliseconds here, a few more there. Your brain holds on to incoming information for a brief window, smoothing it into a single moment of awareness. This window, sometimes called the specious present, lasts only a fraction of a second, yet it becomes your entire sense of presence. You never notice the stitching because the brain performs it effortlessly, like a gentle editor arranging scenes so the story flows. Imagine watching a lantern drifting down a river at dusk. You see the glow, you hear the water, you feel the evening breeze. These sensations do not arrive together, yet your mind weaves them into one moment. The present is a tapestry of slightly delayed threads. This illusion is not a flaw, it is a kindness. Without it, reality would feel jagged and disjointed, broken into separate flashes with no continuity. The brain smooths time so that life feels fluid, so you can move, speak, listen, and breathe without feeling fractured between milliseconds. Yet this smoothing also hides something profound. There is no single now shared by everyone. A person on a mountain, a person deep underground, and a person orbiting Earth would each experience time differently due to gravitational effects. Their now moments would not align perfectly. Even two people standing side by side perceive the world with slight neural delays that make their present moments subtly different. Still, we move through life as if the present were firm ground. We speak of being in the moment, yet the moment is something the brain assembles like a delicate sculpture, remade continuously as new information flows in. Understanding this illusion doesn't weaken the present, it makes it more beautiful. It reminds us that awareness is a gentle negotiation between physics and perception, between what the universe delivers and what the mind creates. The present is not a fixed point, but a soft horizon we are always arriving at, never fully touching. And it moves forward just like everything else. As our understanding of the universe has deepened, scientists have imagined possibilities far beyond our own cosmic horizon. One of the most intriguing ideas is the existence of parallel universes, vast, separate realms where the laws of physics might unfold in slightly different ways. If such universes exist, could time flow differently within them? Could their arrows of time point in directions unlike our own? These questions don't yield firm answers, but they open a gentle doorway into wonder. In some theories, every possible history branches into new universes. Particle goes left in one branch, right in another. A star forms here, fails to form there. In these many worlds, time still flows forward in each branch, but the pathways diverge like an ever-splitting tree. Every universe inherits its own arrow of time, shaped by its own beginning and its own rise in entropy. Other theories imagine something even stranger, that our universe might be one half of a larger pair, born back to back in the Big Bang. In one universe, time flows forward as we experience it. In the other, time might flow in the opposite direction. From the perspective of beings in that universe, they would see themselves moving forward just as naturally as we do. The reversal would be relative, not absolute. Each universe would feel normal from within. The idea is poetic, two cosmic realms expanding away from the same origin, like two waves moving in opposite directions across a still pond. Each wave feels its own forward motion, unaware of the other. What creates these arrows? The same thing that creates ours, the state of extremely low entropy at the beginning. If two universes emerged from a shared moment of order and then drifted apart, each could carry its own arrow, pointing away from that central point like two journeys beginning from the same dawn. Even within our universe, some mathematical models allow small regions where time might behave unusually under extreme conditions, near cosmic strings, inside speculative wormholes, or around exotic matter. But these remain theoretical, beautiful possibilities rather than places we can visit. Speculation like this reminds us that our experience of time is not universal by necessity. It is shaped by the initial conditions of our cosmos, the rise of entropy, and the unfolding of space. If other universes exist, with different beginnings, different symmetries, or different energies, their time might bloom in ways we cannot imagine. Yet here, in our world, the arrow points forward. And it is along this gentle, familiar direction that our lives unfold. To understand why time flows forward, we must look to the moment the universe first became imperfect, the moment symmetry broke. In the earliest fraction of a second after the Big Bang, reality was astonishingly uniform. Forces were unified. Matter and energy were distributed almost perfectly evenly. There was no preferred direction, no distinct structures, no places distinguishable from any other. In such perfect symmetry, time had no arrow. Everything was balanced, poised, timeless. But perfection is fragile. And in the universe's first moments, that perfection cracked. This breaking of symmetry, subtle but transformative, was the first tick of time. Forces separated, particles acquired masses, tiny fluctuations grew into seeds of galaxies. The universe stopped being a smooth, flawless field and began becoming a place with differences, contrasts, gradients. The conditions required for entropy to rise. Imagine a still sheet of water. The surface is so calm that no direction is favoured. Then, a single droplet falls and ripples spread outward, creating motion, structure, and flow. Symmetry breaking is that first ripple in the cosmic pond. Once it happened, the universe could grow, change, and develop complexity. The ripple marked the beginning of a before and an after. As forces differentiated, gravity separating from the strong force, then the weak, then electromagnetism, the universe acquired rules that allowed processes to unfold irreversibly. Temperature gradients emerged, matter clumped, radiation streamed outward. From that point on, entropy had room to expand. This early imbalance didn't force time to move forward, but it created the possibility for forward movement. It gave the universe a path of increasing complexity, and once complexity began to grow, the arrow of time became inevitable. If the early universe had remained in perfect symmetry, nothing would have changed. Time might have existed mathematically, but not experientially. It would have had no direction, but because symmetry broke, the universe could begin to write its story. Every star that formed, every atom that cooled, every galaxy that spiraled outward traces its origin to that first cosmic tilt, the moment when time became a journey rather than a static state. Even today, the echoes of symmetry breaking shape our world. The masses of particles, the nature of light, the strength of gravity, all of these were set in motion by those early ruptures. The arrow of time we feel in every breath began as a tiny imbalance at the dawn of existence. The The universe did not start ticking because it had to. It started ticking because it became uneven, and from that unevenness, everything began. Time surrounds us like an invisible ocean, yet much of what we feel about it is shaped not by physics, but by the stories we create to navigate our lives. We describe our days as journeys, our memories as chapters, our futures as open pages waiting to be written. These metaphors aren't accidents. They reflect the way the human mind organizes experience. In many ways, time is not only something we move through, it is something we tell ourselves. From the moment you wake, your mind arranges events into a sequence that feels coherent. You frame your morning as the beginning of a day. You see meals as markers, tasks as milestones, evenings as endings. None of these divisions are inherent in nature. Sunrise is simply Earth rotating, and years are merely orbits around the sun, yet we imbue these cycles with meaning. We transform them into narrative structures so life feels navigable and grounded. Memories become the past because you weave them together, linking them through meaning rather than chronology alone. You forget countless details, yet a few moments stand out vividly. Turning points, lessons, tender scenes, these become anchors in your personal timeline. They form a story about who you were, which becomes the foundation for who you believe you are. Similarly, the future is not merely a direction entropy pushes us toward. It is a landscape of imagined possibilities, goals, fears, hopes, dreams. When you plan, you're authoring scenes that have not yet occurred. When you worry, you're rehearsing possibilities. When you hope, you're choosing a direction for your story to grow. In this sense, your experience of time is deeply human, shaped by emotion as much as by physics. A joyful afternoon might feel fleeting. A painful hour might stretch endlessly. Waiting slows time. Wonder opens it. Grief thickens it. Love softens it. None of these emotional shifts alter the flow of entropy or cosmic expansion, but they shape the story you tell about your place in that flow, and that story becomes the framework for meaning. It gives your life coherence and direction. It turns random events into narrative arcs. Physics tells us that time moves forward because the universe opens into greater possibility. But psychology tells us that time feels meaningful because we shape it into something we can understand. In this way, time is both cosmic and personal, a river in the universe and a story in the human heart. There is a special tenderness in the way we look back, a song, a scent, a quiet place. Suddenly the past returns in a soft wave, carrying moments we thought we'd forgotten. This feeling, nostalgia, is more than memory. It is a longing, a gentle ache that reveals something deep about the arrow of time. We do not yearn for the future in the same way. We hope for it, imagine it, plan for it. But we long for the past because it is closed, complete, unchangeable. The future is open. The past is a place we once lived. Nostalgia arises when a memory becomes more than information. It becomes emotion, identity, belonging. The past stands still, preserved in the mind even as the world continues moving. We reach for it not because we want time to reverse, but because it anchors us. It reminds us that we have lived, grown, changed, that our story has depth. Imagine holding an old photograph. The colours may have faded, the corners softened, yet the moment remains vivid in your heart. Not because the memory is perfect, but because it is meaningful. This is nostalgia's power. It turns imperfect fragments into something warm and whole. We cannot return to those moments because biology, physics, and entropy all move forward. Cells change, relationships evolve, places transform. The arrow of time carries everything ahead, and nostalgia is a quiet recognition of that drift. It is the emotional shadow of irreversibility. Yet nostalgia is not sadness alone. It can be comforting, a reminder of the people who shaped us, the places where we learned joy, the times when life felt simple or safe. It softens the passage of time by highlighting what was beautiful, not what was lost. Why not feel nostalgia for the future? Because the future holds no fixed shape. It has no established meaning, no emotional imprint, no certainty. We can imagine it, but we cannot long for it the way we long for what has already written itself into us. In this way, nostalgia is another expression of time's direction. We look back with longing because the past is a landscape we can see clearly, even if only in fragments. We move forward with hope because the future remains open, shaped by possibilities rather than memories. Nostalgia does not mean we wish time would reverse. It simply means we cherish the places where our story has already touched the world. There is a quiet truth at the heart of time's forward motion. Once a moment passes, it cannot return. This irreversibility shapes our lives in ways both tender and unsettling. On one hand, it brings a subtle fear, the awareness that experiences slip away, that youth fades, that choices cannot be undone. On the other hand, it carries a profound comfort, the reassurance that healing is possible, that we outgrow pain, that every difficult moment eventually drifts downstream. Irreversibility is bittersweet because it mirrors the essence of being human. We hold on to memories we cherish and grieve the ones we've lost. We wish sometimes for the ability to revisit a moment, to linger a little longer, to say what we didn't say. Time's one-way river makes these wishes tender because they reveal how deeply we care. But this same forward flow protects us. It means heartbreak doesn't last forever. It means sorrow softens. It means change is possible. If time could reverse, wounds might reopen, fears might return, and the past might trap us. Instead, we are carried gently forward, given space to grow beyond what once hurt us. Consider the passing of seasons. Winter cannot become autumn again, nor spring reverse into winter, yet each season brings something new, a shift in colour, a change in air, a different rhythm of life. These transitions echo our own emotional journeys. The constancy of change allows us to evolve. Irreversibility is written not only in emotion but in the body. Cells age, scars form. The mind learns from experience. These changes create identity. Without them, we would be static, unformed, untouched by the world's influence. Time's arrow gives us narrative shape, guiding us into who we are and who we will become. Even the universe reflects this dual nature. Stars burn through their fuel, never to return to their first light. Galaxies drift apart. The cosmic background cools. These irreversible transitions create the structure of reality. Without them, nothing could grow, transform, or begin again. The fear of irreversibility comes from wanting to hold on to what is precious. The comfort comes from knowing that life moves, breathes, heals. Both feelings arise because we are beings who sense time not just with our minds but with our hearts. In accepting that moments cannot return, we learn to cherish them more deeply. And in trusting that time carries us forward, we learn to let go with grace. Stand at the edge of the sea, and you will witness one of nature's most comforting illusions. Waves rise, curl and fall against the sand, then melt back into the ocean. It feels like they're returning to where they came from, as if the water undoes its journey with every retreat. But look closely, and you'll see the truth. No wave ever returns. Each one is made of new water, shaped by new winds, pushed by new tides. The motion is cyclical, but the substance is always changing. This is a gentle mirror of time. We often long for our own waves to return, for moments, seasons, or feelings to wash back onto the shore of our lives just as they were. But like the sea, our lives move forward even when the patterns seem familiar. We experience echoes, not repetitions, rhythms, not rewinds. Each wave that reaches the shore represents countless journeys, heat rising from sunlight, winds stirring across oceans, the pull of the moon shaping tides. None of these processes ever reverse. Even in their apparent back and forth motion, entropy increases, energy disperses, and the world continues its quiet drift forward. Time works like this too. Days feel repetitive. Morning, midday, night. Yet no day repeats. Conversations sound familiar, yet the people speaking them have changed. We revisit places, but the person walking through them is never the same. The rhythm remains, but the water is new. This is why nostalgia feels both warm and bittersweet. It recognizes the pattern but mourns the impossibility of exact return. It senses the shape of a wave we once knew, but also the truth that it has already dissolved into the wider ocean of memory. And yet, there is a comfort in this realization. The sea never repeats itself, but it never stops offering beauty. It creates new waves, new patterns, new forms of motion. In the same way, time does not bring back old moments, but continually offers new ones, gentle opportunities for connection, understanding, and growth. If time ran backward, these patterns would freeze. Waves would retreat before they formed, life would unlive itself, meaning would unravel. But because time moves forward, the world remains a place of renewal, always reshaping itself, always arriving in fresh tides. So when you watch the waves, see them not as returning, but as reminders that life is a series of new movements built on familiar rhythms. Nothing repeats, everything flows, far into the future, long after every star you see tonight has faded. The universe will continue drifting along its quiet, irreversible path. As space expands, heat spreads into emptiness, growing thinner and colder. Galaxies that once shone brightly will dim. Stars will burn through their fuel, collapse, or disperse. Even the faint afterglow of the Big Bang will stretch into wavelengths too long to detect. This is the universe cooling into silence, a slow unfolding shaped entirely by time's arrow. Imagine the cosmos billions of years from now. The Milky Way and Andromeda will have merged into a single, vast galaxy. Most of the stars within it will have faded to embers, red dwarfs glowing softly in the darkness. Around them, planets might still drift, cold and quiet, carrying the last remnants of warmth from ancient suns. As time continues, even these stars will die. White dwarfs will cool into black dwarfs, dense, dark remnants holding no light. Neutron stars will slowly radiate their heat away. Black holes, once the most enduring structures, will evaporate through Hawking radiation, whispering the last traces of energy back into the universe. Nothing in this distant future reverses its path. Every process, from stellar birth to stellar death, follows the same direction, toward deeper expansion and higher entropy. Cosmologists call this distant era the heat death of the universe, but the name can be misleading. It is not a violent ending, but a gradual quieting, a soft dimming, a cosmic dusk stretching across unimaginable spans of time. Though this future sounds cold, there is a strange beauty in it. The universe began in a state of intense heat, a brilliant ordered fireball. It will end in a state of diffuse calm, matter and energy spread thin across space. The journey between these two states is what gives time its direction. It is the grand arc woven through every heartbeat, every falling leaf, every drifting galaxy. In that far future, time may lose its meaning. Once all gradients fade, once no heat flows, no stars shine, no structures change, entropy will reach its maximum. With no more differences to dissolve, no more patterns to loosen, the arrow of time may fade into stillness. A universe without change is a universe without direction. But we are not there. We live in a vibrant moment of cosmic history, warm, illuminated, full of motion. Every star you see tonight is part of the universe's journey from fire to silence, from creation to calm. And for now, we drift within that luminous chapter. Time feels inseparable from change. A flickering shadow, a cooling cup, the slow drift of clouds. These movements tell us that moments are passing. But imagine a universe where nothing changes. No stars forming or fading, no heat flowing, no particles shifting their positions, no memories forming, no rhythms pulsing, no transformations unfolding. In such a place, would time still exist? Physicists and philosophers often suggest that time without change loses its meaning. If every arrangement of matter stayed the same, the concept of before and after would dissolve. There would be no events to separate, no transitions to mark, no flow to perceive. Time in this frozen landscape would be like a river with no current, present only in theory, not in experience. In the real universe, change is everywhere. Entropy increases, stars burn, planets orbit, life grows and fades. These transformations create the markers that allow us to sense time. The arrow of time is not an extra ingredient added on top of reality. It is woven into the behaviour of everything that moves. But as we drift into the far future we imagined earlier, the universe may eventually reach a state where all gradients fade, no heat differences, no atomic reactions, no lingering energy left to drive events. This is the hypothetical heat death, a final quieting where the cosmos becomes almost perfectly uniform. In that uniformity, change slows and slows until it becomes nearly imperceptible. What remains of time in such a universe? Perhaps only the mathematical structure, an empty coordinate with no events to fill it. Or perhaps time itself would fade into irrelevance, as meaningless as a page with no words. This idea may sound abstract, but it reflects a deep truth about our own lives too. Moments feel long or short, not because clocks change their pace, but because we do. A quiet evening with someone you love can feel timeless, as if the flow slows to a gentle drift. A stressful hour can feel stretched, thick, heavy. Time is not only measured by change around us, but by change within us, our emotions, attention, and awareness. When nothing changes in your mind, time feels still. When everything changes, time rushes. So, if the universe someday becomes a place without change, perhaps time will become the softest whisper, a background idea left behind by a history filled with motion, growth, and transformation. For now though, time is alive. It flows through every shift of light, every breath, every heartbeat. Imagine for a moment that time could flow backward. Not just a fantasy of rewinding a video or retracing your steps, but a true reversal. The unwinding of every process, the unmixing of every pattern, the unmaking of every memory. What would such a world feel like? Would you notice the reversal, or would your mind run backward with it, erasing your awareness of the shift? If time truly reversed, heat would flow from cold to hot, smoke would gather back into a candle, broken objects would knit themselves together, stars would compress their scattered light, shining brighter as they rewound toward their birth. At the grandest scale, galaxies would tighten, matter would contract, and the universe would shrink toward a state of perfect order. Yet even in this strange imagination, something crucial becomes clear. You would not remain the same observer in a backward-flowing world. Your neurons, memories, emotions, and thoughts would also reverse. The memory of reading these words would vanish before your eyes. You would remember the future and forget the past. From your perspective, everything would feel normal, because the arrow of time would point backward for you as well. This is why time reversal, though fascinating, is nearly impossible to experience consciously. The arrow of time is not simply external. It is built into the structure of your mind. But even aside from perception, a true reversal is physically impossible because entropy would need to decrease everywhere, all at once, every particle would need to follow a path so precise and improbable that the slightest fluctuation, even the thermal motion of a single molecule, would break the reversal instantly. Nature does not forbid time reversal mathematically, but the odds of it happening spontaneously are effectively zero. Still, imagining a reversed world teaches us something profound. The meaning of time arises not from its direction, but from the existence of direction at all. A universe where everything runs backward would still have an arrow of time, just pointed the other way. Life would still unfold in a sequence, minds would still build stories, experiences would still connect. The arrow itself, not its orientation, creates meaning. And so, the impossibility of reversal is less important than the fact that time has a direction. Whether forward or backward, a temporal flow allows the universe to move, evolve, and become. Without direction, there would be no change. Without change, no life. Without life, no consciousness to wonder about time at all. Beneath the steady flow of time, there is a kind of stillness, a quiet foundation upon which all motion unfolds. Physics hints at this through its deepest equations, whether describing particles, fields, or the curvature of space-time. The laws themselves do not insist on a direction. They are timeless, balanced, symmetrical. It is the universe's unfolding, not the rules governing it, that gives rise to the arrow of time. Imagine the surface of a river. To the eye, the water rushes forward, but dive beneath the surface, deep enough, and the current softens. In some pockets, the water hardly moves at all. Stillness exists beneath motion, hidden but present. In a similar way, the fundamental equations of nature hold a kind of stillness. They work equally well if you play them forward or backward, like a perfect melody that sounds the same no matter how you reverse its notes. Yet from these reversible foundations emerges the irreversible world we inhabit, one where moments slip by, memories fade, and the future unfolds in only one direction. This is one of the great paradoxes of existence. The universe is built on laws that do not age, yet everything within it does. Time's arrow comes not from the rules, but from the conditions, the initial state of the cosmos, the growth of entropy, the complex interactions of countless particles. In the deepest layers of reality, the quantum realm, the space-time fabric, the mathematical structures or YAM, there is no preferred before or after. These layers are like a silent stage upon which the universe performs its story. They do not dictate the plot. They simply allow it to unfold. You carry a version of this stillness within you as well. Beneath your thoughts, beneath the shifting feelings and memories, there is a quiet awareness that does not move at the same pace as mind and matter. Moments come and go, yet some part of you remains unchanged. The witness, the calm center, the steady presence noticing the flow. Meditation touches this stillness. Deep rest touches it. Even a long breath can reveal it. This inner stillness mirrors the stillness underlying the universe. It is not separate from time, but it is not driven by it either. It is the backdrop against which motion appears. Understanding this helps soften the mystery of time. We do not float helplessly in a relentless current. We are part of a universe where movement and stillness coexist, where time flows forward, but something deeper remains steady and silent beneath it. Of all the clocks in the universe, pulsars spinning, galaxies rotating, stars cooling, the one you carry inside you is perhaps the most intimate, your heartbeat. Long before you learned to read a clock or trace the movement of the sun, your body kept time through its own quiet rhythm. Each beat marks a moment, each pulse pushes you forward through your life, tying your personal story to the wider flow of time. The heart is a biological clock, but also an emotional one. It speeds with excitement, it slows with rest, it aches with grief, it softens with love. Though time itself does not change pace, your heart gives rhythm to your experience of it. A joyful afternoon might pass in a flutter. A heavy moment might stretch like an ocean. The heart in its sensitivity converts the universe's steady flow into something deeply human. Even in the womb, the heartbeat begins before consciousness. It is the first rhythm we ever know, and throughout life, it anchors us, a metronome keeping pace with our days. Its constancy mirrors the cosmic processes that also unfold without pause. Entropy increasing, stars burning, planets turning. The heart beats because energy flows, and energy flows because time moves forward. The emotional clock of the heart is equally powerful. Heartbreak leaves a slow pulse of longing. Anticipation quickens it. Peace steadies it. Your heart responds to the world moment by moment, marking not just time's passage but its meaning. In this way, the heart becomes both a witness and a participant in the unfolding of your life. There is also a quiet symmetry between the heart and the arrow of time. Each heartbeat uses energy, releasing warmth into the world, a tiny contribution to entropy's rise. This is not a flaw, it is the very process that keeps you alive. Life persists by creating order within and releasing disorder without, and the heart sits at the centre of this delicate exchange. And when you rest, lying quietly with your breath soft and your thoughts drifting, your heartbeat becomes a reminder of how deeply you're connected to the universe. It is a rhythm shaped by physical laws, refined by evolution, and softened by emotion. The cosmos ticks in pulsing stars and drifting galaxies. You tick in warm, steady beats beneath your ribs. Both rhythms move in one direction, forward, forming two harmonies in a single flowing song. Your heart is the clock that keeps your story, and as long as it beats, time continues its gentle journey through you. We began tonight with a simple, ancient question. Why does time only move forward? And now, after drifting through stars and memory, entropy and emotion, the quantum world and the human heart, we can return to that question with a softer understanding. Time flows forward because the universe unfolds, because patterns loosen, heat spreads, stars burn, and moments leave traces that cannot be erased. Because life builds its fragile order from energy that must be released. Because every breath, every heartbeat, every thought participates in the same gentle direction. Yet beneath all these explanations, something simpler remains. Forward is the only way we know how to live. We wake into new days. We grow from our past selves. We hope toward what has not yet come. Time's arrow is not just a cosmic feature, it is the shape of our lives. Think of everything that brought you to this moment. The memories that softened into nostalgia, the changes that shaped your identity, the emotions that gave depth to your days. None of these could exist without time's irreversibility. If moments returned exactly as they were, nothing would grow. If the future mirrored the past, nothing would surprise us. If time stood still, life itself would never have begun. The arrow of time is not a burden. It is a gift, the quiet current that allows stories to form, relationships to deepen, lessons to take root. Even loss and change, as difficult as they are, give meaning to the moments that come after them. The forward flow is what allows healing, learning, and becoming. So as the night settles around you, feel yourself drifting gently with that current. There is no rush, no urgency, only the soft assurance that you're carried by the same flow that guides galaxies, tides, and the smallest particles of your body. Forward is the direction of growth, of wonder, of rest. You do not need to understand every detail of time to belong to its rhythm. You're already moving with it, already part of the unfolding, already woven into the story the universe is telling. Let your breath slow. Let your thoughts quiet. Let the arrow of time feel less like a force and more like a lullaby, steady, calming, always moving toward a new horizon. Everything flows. Sleep in that motion.